Then this is the chapter 1 of class 10 mathematics. The first chapter is real numbers, and we will study here the number system, prime and composite numbers, fundamental theorem of arithmetic, SCF and LCM, and irrational numbers. First, in number system, first we will read the natural number set. Natural numbers. Which are natural numbers? Natural numbers are starting from 1 up to 1, 2, 3 in this way. These are called natural numbers, and in higher classes we represent it as n set. And next is whole numbers. The whole numbers are all natural numbers belong to these whole numbers. That is 1, 2, 3. These are also whole numbers. That means all natural numbers are whole numbers. And in addition to it, only 0 is there. The difference between the natural numbers and whole numbers is this 0. That is whole numbers. Whole numbers are 0, 1, 2, 3 up to infinite. Next is integers. Integers, we represent this as I. Integers are, that is positive and all negative numbers including 0. That means there is -3, -2, -1, 0, 1, 2, 3 in this way. Initially in the natural number, the numbers were from 1 to infinite, and in case of whole numbers 1, 2, 3 up to infinite. In addition to it, 0 is there. Similarly here in case of integers, that means 0, 1, 2, 3. That means all whole numbers are there. In addition to it, all negative numbers will be there. That is minus infinite to -1. Apart from this, we will read the rational numbers, which is important one. Rational numbers. Rational numbers is represented by Q, and it contains all these negative numbers, or that means all these integers. Negative numbers 0, 1, 2, 3, all positive numbers, negative numbers plus positive numbers, and also including 0. Along with rational numbers are represented in the form of P by Q, where P and Q are integers. P and Q are integers, and Q is not equal to 0. That means integer numbers are just 1 by 2, 2 by 3, 1 by 3. All these are integers. Now we can express any whole number or integers as rational numbers. Suppose we are taking the case of 3. 3 is an integer. 3 is an integer. We can write it as 3 by 1, which is a rational number. That means all integers are rational numbers. All natural numbers are whole numbers. All natural numbers are whole numbers, and all whole numbers are integers, and all integers are rational numbers. Now, on the basis of this knowledge, we will solve some problems. Another thing is missing, that is irrational numbers. We just take it as, because irrational numbers are also real numbers, we represent it by q dash. These are irrational numbers. Irrational numbers are not rational numbers. It is separate than the rational numbers, and it is represented by the numbers as root 2, root 3, etc. are the irrational numbers. And how we will develop the concept of irrational numbers? For this, we have to study some previous class concepts, which is decimal numbers. Actually, decimal numbers are of two types. One is terminating, and another one is non-terminating. Terminating decimal numbers, and another one is non-terminating decimal numbers. Terminating decimal numbers has finite number of digits after the decimal number. For example, 0.75 is a terminating decimal numbers. Suppose non-terminating decimal numbers, we can write this as, suppose 0.333 is a non-terminating decimal numbers. Actually 0.375 is equal to 3 by 4. And non-terminating decimals, this is equal to 1 by 3. But some non-terminating decimal numbers, which is suppose 1.414213, like this, 5623, this is actually the value of root 2. This is not rational numbers. Actually, what are the rational numbers? The rational numbers are terminating decimal numbers are rational numbers, terminating decimal, and another one is non-terminating but recurring decimal numbers are rational numbers. And irrational numbers are non-terminating and non-recurring. Non-recurring means non-repeating. Repeating decimal numbers are rational numbers. This is repeating. Actually, non-terminating decimal numbers are divided into two parts. One is, this is non-terminating recurring, and non-terminating non-recurring. This is non-recurring. Non-terminating non-recurring. Non-terminating non-recurring are, that is root 2. Another one is pi. The value of pi we know, that is 3.14159, like this, in this way. This is non-recurring. So it is an irrational number. This is irrational. This is not rational. Root 2 is irrational. Root 2 is also irrational numbers. So we can conclude here, that means the decimal numbers which are terminating and non-terminating recurring, they are rational numbers, and decimal numbers which is non-terminating and non-recurring, this is irrational number. It is shown in the figure. Natural numbers This is actually represented by n. This is n set. Whole number set. Whole number set contains the natural number set. That means all natural numbers are whole numbers. Similarly, all whole numbers are integers, and all integers are rational numbers. And irrational numbers are not rational numbers. They are separate. All these number set constitutes the real number set which we are reading. Real numbers. All are real numbers. Rational number and irrational number both are real numbers. Rational plus irrational. Now we will solve some questions. The first question is root 3 plus root 2 whole square plus root 3 minus root 2 whole square is a or an positive irrational number. That means we have to find out whether it is a rational number or irrational number. Now here we can write this is a plus b whole square plus a minus b whole square, which is equal to 2 times a square plus b square. This you have to remember. This is the formula, or you can directly take the square and simplify it. Here in place of a it is root 3, in place of b it is 2 plus root 3 minus 2 whole square. This is equal to 2 times, in place of a root 3 square plus b square is plus 2 square. So this will be equal to 2 times 3 plus 4, which is equal to 2 into 7, which is equal to 14. The 14 is a positive rational number. 14 is a positive and rational number. So option A is correct. Also, if you will open these brackets, we will get root 3 plus 2 whole square as 3 plus 4 plus 2 times 2 into root 3, that is 4 into root 3, plus 3 plus 4 minus 4 into root 3, that is equal to 14 also. In this way also you can get. And another question is 1 plus root 3 whole square minus 1 minus root 3 whole square is. So here similarly, here you have to use the formula a plus b whole square minus a minus b whole square, which is equal to 4 times ab. So we can write here 1 plus root 3 whole square minus 1 minus root 3 whole square, which is equal to 4 times 1 into root 3. That is equal to 4 into root 3. This is a positive number. As root 3 is multiplied by 4, so it is an irrational number. So 4 into root 3 is a positive irrational number. Now 0.4 square root is same as 4 by 10 square root, or this is equal to 2 by square root of 10. Square root of 10 is an irrational number. So 2 by square root of 10 is also an irrational number. Is irrational. Because rational by irrational, rational number by irrational number is an irrational number. So option D is correct. Next we will come to prime numbers. The definition of prime numbers is any number having two factors, namely 1 and the number itself is called a prime number. Suppose we are taking the case of a number, it is suppose 31. 31 can be written as 1 into 31. That means its factors of 31 is 1, and 31. So we can tell that 31 is prime. 31 is a prime number. And you remember one thing, 2 is the only even number which is prime. 2 is the only even prime number. All other prime numbers are odd. 2 is the only even prime number. Now, similarly, other prime numbers are 3, 5, 7, 11. These are the prime numbers. Similar composite numbers have more than 2 factors. Suppose you are taking the case of 30. 30 is a number, suppose. So factors of 30 are 1 is the factor, 1 is factor of, 1 is a factor, remember this, 1 is a factor of, you write here, suppose 1 is a factor of every number. So 1, 2 is also a factor of 30, 3 is also a factor of 30, 5, 6, 10, again 15 and 30. So actually it has more than 2 factors. Apart from 1 and 30, it has other factors. So it is a composite number. So hence it is composite. 30 is a composite number. And the fundamental theorem of arithmetic. The fundamental theorem of arithmetic tells every composite number expressed as the product of its prime factors. Suppose we are taking the case suppose 30. The prime factors of 30, if we will see, the prime factors of 30 are 2, 3 and 5. These are the prime factors. So we can express 30, we can express the composite number which is 30 as the product of prime factors. Product of prime factors, that is 2 into 3 into 5. Every composite number can be expressed as the product of its prime factors. You remember, this is the fundamental theorem of arithmetic, and we will use it in finding the SCF and LCM by prime factorization method. First one is, now on this prime factorization, the first question is the sum of exponents of prime factors in the prime factorization of 4004. The number is given as 4004. This can be written as 4004 will be equal to 2 into 2 into 7 into 11 into 13. 2 into 2, 2 into 2 is 4, 4 into 7 into 11 into 13. That means we can express the numbers, this number, as the product of its prime factors. That is 2 into 2 into 7 into 11 into 13. That can be written as 2 square into 7 to the power 1 into 11 to the power 1 into 13 to the power 1. The prime factors you have to find out by, suppose first you divide by 2, it will be equal to 2002. Suppose 4004, we divided by 2, it will be 2002. Again divide by 2, it will be 1001. Divided by 7, it is 143. Divided by 11, it is 13. So we can write it as That is, in this way we can write, this is 2 square into 7 to the power 1 into 11 to the power 1 and 13 to the power 1. The sum of the exponents, so sum of exponents will be equal to 2 plus 1 plus 1 plus 1. These are the exponents. Here it is 2, it is 1, it is 1, it is 1. So this will be equal to 5. The sum of exponents will be equal to 5. Now second question is a to the power b is equal to 32. Here a to the power b is equal to 32, where a and b are positive integers. The only case satisfies this is equal to 2 to the power 5. This implies a is equal to 2 and b is equal to 5. Now we have to find the value of b to the power ab, which is equal to 5 to the power 2 multiplied by 5, that is equal to 5 to the power 10. So the option B is correct. Okay, next class we will discuss other problems and the SCF and LCM of the numbers, of two numbers actually. Thank you.